How's it go, 12s? Today we're going on to series. Just to explain what series is, if we go back to a sequence, now you know a sequence is a list of numbers that has a rule that we go from term to term to term. Now you've seen two types, or three types rather. You've seen an arithmetic, you've seen a geometric, and you've seen the quadratic. Okay, each one of them have their own separate rules how we get from term to term to term, and it's just a list of numbers. Okay, so a series now is exactly like a sequence where we have a list of numbers and there's a rule that we're going from term to term to term, but instead of just listing the numbers, like for example T1, T2, T3 and so on, we are now going to add all of those terms together. Okay, so if T1, T2, T3, so on up to Tn denotes the sequence of which the nth term is Tn, then the sum T1 plus T2 plus T3, so on and so on, is called the series of which the nth term is Tn. So a sequence, just a list of the numbers that has a rule going from term to term, and then a series is you're going to add all of those numbers. If only the first n terms of a sequence are added, okay, so we only go add up to Tn. We have a finite series or a partial sum because we can't carry on adding indefinitely, okay? We can only go up to a certain amount. If we use all the terms of the sequence, we have an infinite sequence, okay? So we have a symbol that we can denote the sum, okay? So sigma notation enables series to be expressed concisely. Okay, so all sigma means, and you can make a note of this, is it just means sum of. Basically what you're going to do is you're going to add the terms. Okay, so the symbol sigma k is equal to 1 up to n of tk means you're going to add T1 to T2 to T3 all the way up to Tn, and is read sigma tk from k is equal to 1 up to k is equal to n. All right, so having a look at example 1, evaluate sigma of 3k minus 2 from k is equal to 1 up to 10. Now the value k below the sigma gives the first integer to substitute. In other words, this is your starting value. Okay, that's where you're going to start. Then the value at the top is the number to substitute for k to get the last term. This is where we're going to stop. So this is the last value to substitute. Okay, and what's going to happen here is we're going to increment it. So we're going to start when k is 1, then k is 2, k is 3, k is 4, all the way up to 10. All right, the value below sigma need not be 1, so we don't have to start at 1. We can start at 2, 3, or whatever. Okay, sometimes r and I can be used instead of k. Now this variable over here, k, is just a dummy variable. We can make it whatever we want. So like what they said here, r, I, m, whatever. Okay, the sigma notation indicates either the series or its value. Okay, so that's just talking about sigma there. What we're going to do now is we're going to actually expand some of these sigmas. All right, so we need to expand this. So what this is going to be equal to is we're going to start where r is 1. Okay, and I just substituted in here. So I'm going to do the first one. So we've got 2. Now r is 1 squared plus. Now I go to when r is 2. So we've got 2 times 2 squared. Okay, I'm just substituting for the r. Plus 2, 3 squared. And I'm going to carry on doing that until I get to 7. Plus 2, 4 squared. Plus 2, 5 squared. Plus 2, 6 squared, and then the last one, 2, 7 squared. Okay, Now, I don't have to find out what this exact value is because they just asked us to expand it, okay? What would we do later on? I'll show you in a later lesson how we solve that. Okay. Example 3. Now what we actually have to do is now we have to evaluate. So we have to find an exact solution. So what I'm going to do is now we're going to start at 4. So wherever I see an R, I substitute with a 4, then I go to 5, 6, and then we stop at 7. Okay, so let's do the first one. So we've got 4. 4 plus 2. Plus 5. 5 plus 2. Plus 6. 6 plus 2 plus 7. 7 plus 2. Okay, and then I stop there. So now what I can do is I can evaluate this. So over here we get 4 plus 2 is 6. 6 times 4 is 24. Plus 7 times 5 gives us 35. Plus 8 times 6 gives us 48. Plus 9 times 7 gives us 63. And then we can just add those numbers together. And we get a total of 170. Okay. Example 4, evaluate sigma 2 from k is equal to 1 up to 8. Now, if you notice with this example here, there is no variable k here. So all we're going to do is we're going to add 2 8 times basically. So we've got 2. Now I just want to make a note here. This is when k is equal to 1. Plus 2. This is when k is equal to 2. Okay, and you see there's nothing for me to substitute in, so I'm just adding this 2 all the time. So let's do it when k is 3, when k is 4, sorry, when k is 4, when k is 5, when k is 6, when k is 7, and when k is 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8, which gives us 16. Okay. Right, grade 12, so what I would like you to do is exercise 1.7, numbers 1 and 4 for me, please. Thank you.